Okay, so let's go ahead and get started. Today we're going to kind of do a little quiz review 6.1 and 6.2. And then I'm going to talk a little bit, probably at the end of class, I'll talk a little bit about Lab 5. And then we're going to cover central limit theorem today. 6.4 I'll probably cover next class a little bit instead of today because it's not actually on the exam. You have Connect Math 6.1 due today. Sunday, you have homework due on Sunday. 6.2 is due on Sunday. Here's the thing. For your z-scores, you have to use only 2 decimal places. Because the way I have it set up in the homework, I've chosen the option where you would theoretically use a z-table. Don't use a z-table. The directions, if you guys do the help buttons, it'll tell you to use a z-table. Don't use a z-table. Do normal CDF like we normally do. But do normal CDF like as if it were a z-table, which means you only use 2 decimals for z-scores, and you round to 4 decimals for areas. So everyone know what I'm talking about? So just, you want to find an area, do it like we've been doing with normal CDF, except for only use 2 decimal places for z-scores. So if your z-score is 1.63792, round it to 2 decimal places and use that. And then round to 4 decimal places for the areas. There may be like a 1 in 3 chance you might end up with a spot where this creates a small, tiny rounding error where your answer might be off by like 1 decimal place on the very last spot. It'll only happen to like a third of you. So if you have used 2 decimal places here and 4 decimal places for area, and you kind of think you've done nothing wrong, you kind of double check, then just add, on your last digit, add 1 and see if that works, and that doesn't work, then try subtracting 1 and see if that works, because sometimes it's off. The way that it does it is, it finds the z-score from there to the end, you know, from say you want to find the area between a z-score of -1 and +1. What it does is, what you guys do is you do normal CDF of -1, -1, right? What the table does is it finds the z-score from -∞ to -1, and finds the z-score from -∞ to 1, and then subtracts those. So sometimes it's off by a tiny bit. All right, but definitely for 6.2 and 6.3, you have to use only 2 decimals for the z-score and only 4 for the areas. Your exam 2 is on Thursday, March 12th. That is a week from today. Covers chapters 3, 5, and 6. I will do a review session next Wednesday, March 11th, in 6:01 from 6:30 to 8. Bless you. So let's jump in on what we've got. Exam 2. Don't forget, there's 2 parts. The first part, I will use a very basic calculator. It can add, subtract, multiply, divide, that's it. Who needs one of those to borrow? Only 3 people? 4 people, that's it? All the rest of you guys have one? Okay. So I will bring some. I should have enough for the 6 of you. The rest of you guys should, I guess, bring your own. And then, again, that covers chapters 3, 5, and 6, but not 6.4. And you're allowed 1/2 page, one-sided of notes, handwritten by you. There's also ways of getting extra credit, like before. So bring those in if you need them. Quiz problem number 1. Which 4 terms can be used interchangeably when working with normal distributions? Talk to your neighbors for 10 seconds about this. Go ahead, talk to them. Okay, so is anybody still confused, possibly? Take a look at this slide. Alyssa Q, go ahead and read.
To summarize one point, area under the curve equals probability equals the sum of population in that range.
Thank you. All right, so your area under the curve, bless you, is the same thing as your probability. So here's my area under the curve. Here's my 2 z-scores, 2 values. This area under this curve is the same thing as the probability that someone is between these two values. Is the same thing as the percent of population that is between these two values. So those are the same thing. They all add up to what?
1.
Yeah, the area under the curve. If I add up all the area under the curve, what was that up to? 1 or 100%. If I add up all the probabilities of everybody, what will that up to? 1 or 100%. If I take the entire population, what percent of the population will I have? 100%. Right, so those all represent percentages of the population, probabilities. So, go ahead and fill this out. I will give you guys 15 seconds to fill this out with your neighbors. Go ahead. What's one of them?
Percent of population.
Percent of the population. Okay, find the other. There's two more I just said, plus another one that that they all represent the same thing.
Area.
Area, great. Probability. Good. And then what else is the same as probability? Or percent of the population? Relative frequency. Relative frequency is right how that's a ratio of your percent over the whole, right? Sort of that percentage of the population. If you add up all the relative frequencies, what do you get?
1.
1. Okay. How do you use a calculator to find the area under the curve? The percent of the population? Normal CDF. That gives the area between two z-scores. How do you get there? You do second bars, and then under distribution you go down to the second one, which is normal CDF. That would give you something that looks like this, and then you put in your lower z-score, comma, your upper z-score. So you just type in whatever your lower one is, lower z, comma, your upper z. If you have a fancy calculator, then like a really kind of more advanced AD4, then it may give you a prompt for the upper, or the lower, sorry, and you put the lower z-score in there, and then you arrow down to the upper, and you put the upper one in there. You leave your mean at 0, and your standard deviation at 1, if you have one of those fancier calculators. And then you hit calculate, and then enter again, and it'll calculate it for you. Aha. So, these problems, you're always going to have either two values, two z-scores you want to find the area between, or you're going to have one value, or one z-score, and you need to find the area below it or above it. The area less than it or the area greater than it. It's always going to be either 2. If I give you 2, then you find the area between them. If you get 1, then it better be that you're looking for the area above it or below it. So, here's one where we just have 1. And I'm looking for the area, is this above it or below it here? Below it. So then, I need to figure out what the other z-score is. What's the z-score way out here, guys? Negative infinity. So that would be your other z-score. You go all the way to the end, and your z-score would be negative infinity. How about this one down here? Here's my z-score here. And am I going above it or below it? Above it. So then what's the z-score way out here? Positive infinity. Good? Everybody understand this okay? If you only get one value or one z-score, then you're looking at above or below it. If you get 2, then you're usually looking for the area between them. So everybody see the difference there? Okay. So this one is find the probability using the standard normal distribution. So the very first thing you should be doing with this, always, 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 especially if you want to get full credit on the exam coming up, is you're going to draw a picture. Draw your little hill, draw the ground across it, and just put a slight dash here, a notch in the middle. Do not, let me say this again, do not draw a line straight up like that. Because what that's going to do is it's going to tempt you to shade from that line or to that line, and that's not correct. So do not do that. Just put a notch only. Did everybody hear that? Only a notch at the middle. Then, what's the number we care about? Z being 0.75. Is that on the left or the right?
Right.
On the right. Somewhere on the right, 0.75. Draw a line all the way up. So then I better be looking, I only have one, so I better be looking at greater than or less than. Which one is this? So here's my little fishy, right? And again, the smaller one's easy to catch, so he already ate the smaller one. Z is the larger one. Larger fish are hard to catch. So the Z is larger. So if Z is larger than this, where is Z? On this side or this side?
Right.
This side over here, the larger side. So this is what we want, this side over here. All right, so then I need to find the z-score at the end of this. I have it on the lower side. I need to find the z-score on the upper side. That's going to be what? Positive infinity. So this is exactly what you need to have on your exam. You need to give me the hill, the line, the notch. Put in the number you care about, straight up, and shade the appropriate side. And then, figure out where the other one goes, if you have another one. Or, if you have two, put those in. And then, what's the next thing we do? Anyone?
Normal CDF.
Normal CDF. Normal CDF. And my lower one is 0.75. My upper one is infinity, or pick your grandmother's age. Some old, just a large number. 91. And what did you guys get?
0.2266.
0.226?
66.
666?
Yeah.
Okay. So 67?
No, 66.
6. Oh, okay. So it goes smaller. The next digit smaller than that.
Yeah.
Great. So that means that this area here is I should use this one. 0.2266 inside of here. That's the probability inside of there. Do you guys need 30 seconds to check in with your neighbors on this?
Yes.
Okay.
Are you picky with the decimal places? Because that could point
Yes.
to 227.
Oh yeah, I need 4 decimal places on the area, 2 on the z-scores. 4 here, 2 there.
That's what she just said 2 minutes ago. Literally just said that to me. That's why you need to bring extra.
Okay, so it seems like people are talking about other things now. Applications. Again, the application in Mahika is just one extra layer. So instead, we're saying, what's the area, instead of saying, what's the area between a z-score of blank and blank, we're saying what's the area of a, in your sample was, what's the probability of having a candy bar with calories between this and this, right? So we're used to doing things with z-scores. So it's just one extra step. Take whatever values you have, convert each value to its z-score. Once you convert your value to a z-score, then it's just what we've been doing. Draw a picture, put in the z-scores, shade the area between them, and use normal CDF. How do you find the z-score? Take every value, subtract the mean, divide by the standard deviation. So again, these are the steps if you did not write them down. They, I think, are on the bottom of page 7, maybe, perhaps. No, bottom of page 5. 4, on page 4. 6.2, on page 4. The first step, Rob, go ahead and read for us. Rob, go ahead and read for us.
To find the area between two x values, convert data values to z-scores, draw a picture, use normal CDF to find the area between the z-scores.
Right? So just adding this one step above everything else. So just first take your data values, convert each data value to a z-score. And then just like we've been doing before, draw a picture, put in your z-scores, use normal CDF. So here are the steps. I kind of have drawn sort of a picture of it. So the first step, convert every x value to a z-score. And then the second thing would be drawing a picture. And the third thing, sorry, so the second I drew a 3. The second thing would be drawing a picture, and then the last thing would be using normal CDF. And I did this one as an example. And remember I said 2 things. One, I don't ever put this line here. It makes things confusing and it'll screw people up. Because you're going to want to, people will start shade to it, and it's not, that's not a stopping place. It just should be a notch. And then also, I think it's confusing sometimes to have the numbers there maybe, so maybe we'll just keep it clean and we just put z-scores in there. So here, the first thing we're going to do, what's 5.2? Amita, what's 5.2? What's 5.2?
Oh, my mean?
Yeah, it's your mean. What's 0.3, everybody?
Standard deviation.
Standard deviation, that's our sigma. And then we need to figure out the percentage of people who have less than 5.4 liters. That is our x. So we need to change our x to a z-score first. How do you do that? Figure out how far it is from the mean. 5.4 minus the mean. Then divide by standard deviation to get that in standard deviation. So this is 0.67 standard deviations above the mean. Great. So now we know our z-score. Now we can do the rest of it. We're going to draw a picture. Put a little notch in the middle. And then where does 0.67 go? On the right. Somewhere on the right. 0.67. And do I want above this or below this? Above this amount or below this amount? Less than. So less than is what? The left or the right, guys? The left. Exactly. So we're going to shade on the left. Which means that my other z-score is going to be way out here, negative infinity. So then my last step will be normal CDF of some large negative number, negative 84, comma 0.67. And that should give you this area in there. All right, so you had one very similar to this. You had the chocolate chip cookie problem number 4 in your quiz. Do you guys need like just another 5 minutes to finish that up? Please note that, you guys, this part here means, what does this mean in words? In other words, use the words calorie and chocolate bars. Those better be in that explanation somewhere. Okay, so take a few minutes and 5 minutes and work.